Welcome students to our class. In this class, as like in every other videos, in every other lecture, we come up with a new topic named very interesting topic in the field of mathematics. Likewise, also we come up with a new topic. As you can see in the screen, it's written as element addition in a matrix and its arithmetic progression. So the students those are belong to class 11th, 12th and engineering, only those students are able to understand this topic, but it is not up to this much. The students other than this class or other than engineering branch can also watch this video. It is free for all. You can enjoy, you can learn something new from this. Okay, so let us start the topic without wasting any more time, because time is very important. You have to value the time, then only time values you. So in every other videos likewise we are also starting with the contents, so that before I go to teach you, before I go to guide you, you should understand what was the topics we are discussing here. So as you have seen, like here there is a two topic. If you divide this whole topic, it is in two part. One is element addition and other part is arithmetic progression. So uh, of course you must know what is an arithmetic progression. Maybe it is not necessary to uh, learn to give you the lessons of that, but we also going to see that can a matrix be how a matrix can be denoted in the form of arithmetic progression. And you first know to understand and what is element addition in a matrix. Okay, what is element addition in a matrix you first have to know, then only its application part is this one, arithmetic progression. So you must know, you may now got the point that we are talking about two topics, one is element addition and one is arithmetic progression, as the contents here likewise. So first of all we will talk about the element addition in a matrix, and under that there will be coming one S factor. What is that S factor? We will also going to learn about it, and for that S factor we have some calculation part also we are going to learn. And after learning these two topics, we are going to finally learn the general formula for element addition in a matrix. So likewise you have learned many formulas of matrix and determinants. Like if you talk about determinant, how to calculate a determinant. If we talk about row column operation, how to apply it, how to calculate rank of a matrix, you must know about these much things. Okay, you know about these all things. Similarly, this topic also having a general formula, and by this formula we will have one more topic here not written, which is arithmetic progression. Sorry students, my handwriting is not so good. Please cooperate with us, and I am also dictating the things whichever I am writing here. It is arithmetic progression. One more topic is there. After this third topic, only this fourth topic we will going to study about it. And there is a very little topic, matrix notation of element addition in a matrix. A very small topic is also there. It is not that much important topic. And at last we will talk about the limitations, because it's a top research, and you know that every scientific research or any other research have some limitations, have some disadvantages. Likewise, this research topic also having some limitations. Also, we are going to learn about it. So I hope you all understand the contents of this lecture. So before I go to the element addition in a matrix, I am going to tell you the basics. Basically, you know that element A can be written as, so I am writing like this: A B C D E F G H I. Of course, you the general notation is A11, A21, A31, A12, A22, A32. Likewise, the notations are. But for simplicity, I am just writing like this. Okay, and it having, definitely it has a determinant A, it having a determinant A, and I think it's not, I'm not going to tell you how to calculate the determinant A. You all know about the formula. So here what we know that A, B, C, D, E, F, so on, H comma I are elements of the matrix. Okay, these A to I are the elements of the matrix. Okay, so what you mean by the element addition? What do you understand by element addition? See, let me clear one thing, that you have learned about the matrix addition. You have learned about the matrix addition, that two matrices A and B gives you a new matrix called C, but the condition is that all should be of n by n matrix, means equal number of rows and equal number of columns. Well, not n by n, basically n by m we say. N by m is basically the notation, but we are dealing with our square matrix, so that's why we are taking a square matrix. Okay, so you know that suppose B is another matrix, let's say P Q R S T U P W X. Okay, so what will be the A plus B? Simply you will add the matrix of same order, means A plus B, B plus Q, C plus R, similarly likewise I plus X. You add like this. So you know this is the matrix addition. Okay, this is the matrix addition, but we are talking about the element addition. We are talking about the element addition. That means I have to add any integer I can add any integer or any fraction. Of course, any real number I have to add. I have to add any rational number, not real number. Any rational or real number, anything you can take. I have to add any real number in the matrix. Suppose let us rough this matrix B. We are roughing this matrix B. So what is, so I'm denoting with A dash and I taking one, wait, before that, if you know element addition means I can add any number, any real number to any of the element, right? That means I can add a 1 to A, I can subtract 2 to B, C is left like that. I can do this way, adding D4 and subtracting 1 from E. So likewise, suppose I plus 6. So this is generally the meaning of element addition. This is the general meaning of element addition. Okay, this is the meaning of element addition. But this addition is not benefit for us. It will not beneficial for us. So what our research saying that you should not add. Sorry, it is rubbed away. Okay, I'm writing once again. Our research saying that instead of adding different integer or real number to any of the element, I just add one element. Up to now I am just for your understanding I am uh, dictating integer, real number, rational number, but from now on I am just dictating element. I will call it as element. Okay, I will call it as element. I will call it as element, and this element is of any type. It may be a decimal, it may be a fraction, it may be an integer, it may be any real number. Okay, so I am just adding one element x to all the elements. I will add all the elements in a matrix. Okay, I will add. So our research says that instead of adding different elements, I will just add one element to all the elements in the matrix. So that means what will be my new matrix will be then I'm denoting with A dash. I will explain you also that why I am writing A dash, why I am denoting A dash. It can be write like this: A plus x, B plus x, C plus x, D plus x, E plus x, F plus x, G plus x, H plus x, and I plus x. So this is our research saying that instead of adding different element in the elements of the matrix, I will just add only one element in the matrix. And I have also, you have to keep remember to you that you should remember determinant of A. And you know what is determinant of A. So let us erase this part. I hope you have written all these things. Just learn and listen whatever I am going to speak about here. So I need to find determinant of A dash. And of course, your mind will says that your mind will say that I have to do row and column operation. But our research suggestion says that you should not do the column and row operation. It will not give you a exact answer. Okay, it will not give any exact answer. Okay, so what we will do, just like the formula we are doing this way, e plus x. So if it is it is numerical lecture part, we can skip. But as it is a research part, we are going to explaining everything so that you will understand. Into I plus x, h plus x into f plus x, right? Plus f plus x. Okay, we have to do like this. So if you solve this, you will come to one conclusion that coefficient of uh, x square will become 0. You will come to one conclusion that uh, coefficient of x square will be 0. If you solve this, just I'm going to solve one part of it. Just let's take this one. It, okay, going to solve one part. So as we have written a plus x, if you open it, it will be ei ei plus ex uh, plus xi plus x square minus HF minus HX minus Fx minus x square. It will opens like this, and you see here x square get cancelled. So here we have, so you see, so I am separating both a and x. Okay, this is I. Okay, this is I. So if you see, if you multiply with this and this and this and this, okay, if you multiply these four elements, it will be coefficient of x square. Coefficient of x square. Similarly, there are two more elements left. Okay, and you have to solve like this. You will come to a conclusion that every element of x square means every coefficient of x square will become 0. Okay, will become 0, and we left with this one. These are constant, and we have having a coefficient x also. So there will be a huge research, huge derivation has been done. So if I will going to explain that derivation, it will take lot of time, and you also may be not interested. So we are coming into a conclusion part. We come to a conclusion part that if you calculate it, will come to a conclusion part. It will come like that a plus sx, sorry, it will come to a conclusion part that a plus x sx, where this s is called as, for our terms we are just, for now we are denoting this as multiplying factor. We are denoting it as multiplying factor. Okay, multiplying factor. Okay, so these are the things. Right now we have researched for only 3 by 3 matrix. For 4 by 4 matrix things will be different. For 5 by 5 matrix things will be different, and also for 2 by 2 matrix things will be different, but this notation will be same for every case. You can see here a number x is added to each element of the matrix A, and such that new matrix A does become, as I have written, it has been written in a clear format. My handwriting may be not understandable to you, so you can see through these lines, and this will be the case. Determinant of A becomes, A dash becomes, and S is the multiplying factor of the matrix A. Now you will be wondering, what is this S? What is this S? From where this S has been come, and what is the role of this S? Okay, let's see over there. So coming to the calculation part, the calculation of multiplying factor S. So here this is the formula given, but as you see this formula looking so much weird to you, it is very complicated is looking to you. So I will tell you how to calculate this one. Okay, so let's see here. The S value will be getting from the matrix A only, not from new matrix. New matrix determinant will coming from old matrix, the original matrix, and the S value also coming from the original matrix only. So this multiplying factor, how to calculate? Just see. Let's take the matrix again. Okay, so this is the matrix. So what you have to do to calculate, just like the determinant, the importance of signs are there. Similarly, in calculating the S factor, the importance of signs is also there. So likewise the minus says this will be plus, this will be minus, this will be plus. Okay, this will be plus. So similarly we have to do what you have to do. First you take element A, or you can take any element. The first element you can take. I'm taking A, and if you finding the determinant, what you are doing, just cross multiplying and you are subtracting it. You are cross multiplying and subtracting it, but here what you have to do, just take these cross elements. First you take the left to right corner elements, upper left to lower right corner elements, I mean to say upper left to lower right corner elements you have to take and add these two elements. Okay, you have to add these two elements. Now let me take another color. You have to take remaining two corner elements, lower left to upper right, and you have to subtract these two elements. Okay, I think you are able to see this. Okay, that is E plus I minus H minus F. And let me take another color. Again you have to take the same element, likewise you do for the matrix determinant. You have to multiply this and add it, and remaining two corner elements multiply and subtract it. So this is how you have to find S, but this is for element A only. This is for element A, and similarly you have to do for element B and C. So let me do it once again and write down it. Okay, so this is element A. So as you see, calculate S value. This is E. Okay, don't confuse with C. So this is as I explained just before. Same way you have to do this. You have to write like this. Next, now I am taking minus as minus minus saying likewise. This will be negative, and similarly you have to take upper left to lower right corner elements and add it. That is D plus I, and take lower left upper right elements and take it subtract each one minus G minus H. Then multiply the two first elements and add it, then multiply the other two corner elements and subtract it. And finally we are going for C. It will be D plus H minus G minus E plus DH minus GE. So actually this is the S value. So this is the S value. Okay. So this S value comes from the derivation. It is comes from derivation, and if you add if you add n number of elements in the matrix A to each element, this S value will remain same. I will tell you later. There is a application of it, but keep remember one alert I want to say you. Don't do row or column operation. Why? Because if you do row and column operation, each element is changing its own value. So if you suppose take Suppose A value is 5 and B value is 6. If you add suppose an element 2 in 5 and 6, new element become 7 and 8. Okay. But suppose I do row operation, that is R2 minus R1, it will be 6 minus 5, which is 1. And if you add 1 with 2, it will give you 3. Suppose the first upper element is still 7 after addition of 2 in the elements. Next element become 1, and that's entire second row's elements has been changed from the first one. What will happen? This determinant will definitely change. The S value will be changed. So you have so this is the reason that do not do row or column operations. All these things has been found out from the research. Okay, so this is the value, and there is only one option you can remember this S value. Practice, practice and practice. You have to do lots of practice. You can practice it by doing lots of question, by making question of your own. You are so much up to this stage you are that much intelligent that you can make a question of your own self, and you can practice S value also. So I have also remembered this as value by practicing and practicing. So only the thing you can do is practice. Keep doing practice. It will able to remember this as value. Okay. So yeah, this is the S value written in a clear format. You can see. Okay. As and these are the steps, but these are not required much. I have explained you the steps very easily in an efficient way. I have explained the steps. Don't read these things. Otherwise, it is up to you if you want to read. But the things has been written here are not explained properly. That's why I am requesting you to don't read these things. Just doing practice, it will be easy for you. So now next come to the general formula of element addition in a matrix. Okay. So let me clear this part if you have written. Otherwise, you can take a screenshot, or you can rewind the video also if you want to write these things. So one thing I have, so as you see, we have learned that determinant of A does will become, okay, det A plus Sx, det A plus Sx. Okay. Now, what is this dash? This represents one time Sx. This represents one time Sx. So now what will be A double dash, then it will become A dash plus Sx. And you should remember I'm not saying that on the same element you have to add Oh yeah, same element. Uh, Same element, or you can take different elements also. But if you see on the screen, I have written X. I can written Y also. If I'm taking different element, but this S remains same. Okay, but don't do row and column operation. Then S will be changed. You very well you know that upon row and column operation determinant of the matrix will become same, but not in the case of S factor multiplying factor. Okay, so come to the point that if S remains same, then I can write the equation like this: determinant of A double dash equal to determinant of A dash plus Sx. But I know that what is determinant of A, I know. So I will substitute this determinant of A dash. It becomes plus Sx plus Sx. Okay, it becomes this one. So this is, so this double dash represents 2 times. Okay, as you know that in the case of derivation, if you write f dash x, this 1 dash represents one time derivation. If you write f double dash x, it represents 2 time derivation. You okay? So likewise here in the case of matrix addition, element matrix addition, or I say element addition in a matrix, this represents how many number of times Sx has been added. Okay. So similarly, if you do upon like this, you will come to a conclusion: a power n determinant is equal to that a plus n is x. Okay. Likewise, we are this way only we make the general equation. Okay. So likewise, this is that a plus n as x. And this n represents number of times sx added, and we say this one as general equation. We in this way it is called general equation. We represent. So this is the general equation. Now will add if I add 2, means if I add 2 in all the elements 5 times, so I can get my answer, means 5 times repeatedly, not at a all, not all at a time. Not all at a time means you should not add 5 in, you should not add 2 5 times in one go. You have to add 2 5 times in each successive new matrices. Successive adding I am talking about, and by this way you will find new matrix whose determinant will be this one. This one will be the matrix. So this is the general formula. Same things has been written over here. You can look over here. So this is the general equation or general formula. Okay, where n is equal to number of times element x is added. So now we take some cases. We're taking some case. So one case is that so you cannot change your n, you cannot change your s, but you have option to change x varies. You are able see you can not change n here. You cannot change s, but x is varies. It is your choice. You can take any x value. So some cases are has been discussed here that as you know x is a real number. So if x is equal to determinant a, first case is that if x is equal to determinant of a, so if you put here you will solve by yourself and you will get one result. Okay, you will come to this point. So this is a multiple of determinant a and 1 plus ns is its factor. 1 plus ns. Okay, 1 plus ns is its factor. It is multiple of determinant a and the factor of this multiple is 1 plus ns. Okay, suppose consider consider x is equal to s. Then you will get answer as oh sorry, suppose you consider s as x, your that a power n becomes that a plus n s square, right? In place of x you are putting s, so s into s it becomes s square. Okay, suppose if determinant of a is 0 means this value becomes 0, this value becomes 0, what will be that a power n, it will equal to ns x. Okay, but here we cannot say that a power n is 0. We cannot predict. Why? Because it's not necessary that every successive a power n determinant will be 0. It's not possible because n is not known to us, and maybe any one value of n in which its determinant becomes 0, but not in every cases it's necessary to be 0. If a power n becomes 0, then definitely that it has first of all must be 0. If first one will 0, then only a power n becomes 0. Okay, so one more case. If a is I, identity matrix, so one point you should remember that the S is equal to diagonal sum of I. Okay, if you know that I is what, if you know what is I, you know, if you know what is I, then S will be diagonal sum, means 3. And if A is I, then you know that determinant of A will becomes 1. So what will be your that A power n? It becomes 1 plus 3nx. It will become 1 plus 3nx. Okay, you can derive by yourself these cases. Here are the cases has been discussed. If x is equal to det A, then that A power n is equal to that A times 1 plus Sn. A that A power n is a multiple of that A with multiplying factor of 1 plus Sn. If x is equal to S, then this is the case. If this 0, this will be the case. But just a minute, students. We cannot predict this one, okay? And this is last case. A is identity matrix. This will be the case. This is the formula. And one more thing, in case of 2 by 2 matrix, this will be the multiplying factor. Okay, this will be the multiplying factor. The first rule, the first part you have to do, that is you have to do. Multiplication part is not here. Okay. Okay, students. Now I think you all understand this. So now we are going to do some examples. You can see the example on the screen. Here is a matrix P is equal to 1 3 5 3 2 4 0 4 0. If each element is added by 2 in the matrix, what will be the determinant of the matrix P does? Also find B double dash and B triple dash for the same. So what is the purpose of this example that whatever the formula I have teach you, you can relate to this example that this formula is actually applicable for this purpose. So let us try to solve this. So this is the matrix B. Okay. So I'm starting from the solution that I will add each element by 2. I will add element 2 in all the elements of the matrix and I will make a new matrix B dash. So B dash will be what? So I'm going to do it step by step. So basically it's saying add all the elements by 2. Okay. So first of all I am going to solve it by manually in the process. Second step I will use the formula and I will correlate both the answers. 3, 5, 7, 5, 4, 6, 2, 6, 2. Okay. So this is the new matrix P dash. So as the process you have to find the determinant of B dash. So 3 into 4 into 2 8 minus 6 into 6 36 6 into 2 12 minus 6 2 into 6 12. It is not 6. So the student it is not 6, it is 5. Little bit typing writing problem. Ten minus 12 40 minus 8. If you solve this, you will get your answer as 80. You can solve by yourself, you will get the answer as 80. So this is the general method 1. And now we are going to solve it by method 2. So I am writing the matrix here. If you know the formula, it is okay. So here your x is what? Because you are adding with 2. You are adding with 2. So remaining you need B dash and S. So you can calculate the B dash, I mean B. If you calculate B, you will getting 44. You will getting 44. So now I'm just not calculate this one. I'm going to show you how to calculate S. If you see upper left and lower right elements, you have to add this 2 plus 0, and lower left and upper right elements you have to subtract. Then you have to multiply upper left and lower right elements, will be 0, right? This one, and now this one minus 16. Okay, so this way you have to do. And minus 3 into, similarly if you do 3 plus 0 minus 0 minus 4 plus 0 plus 0. Okay, then 3 plus 4 minus 0 minus 2 plus 12 plus 0 minus 12. Okay, in this way you have to do. Upon solving, you will get 18. You solve, you will get S value 18. Okay, so now here I am writing and S is equal to 18. Okay, so what we do now, use the formula. Here it is B, so I am writing B dash. It will be coming 80. It will come 80. So by using this formula also I have calculated. Okay, so we have calculated this part, and also we have to find determinant of B double dash and B triple dash. So if you remember the general equation, then it's very good. Otherwise I'm writing over here. So let me do one thing. This x into x is what? 18 into 2, 236. Okay, I'm just doing this part now. Okay, first of all, find b double dash. It will be that b plus 2 into sx value is 36. It will be what? 44 plus 72. You will going to get 116. Or this way also you will find you know this value 80 and this value is 36. This is the answer. Both cases you got the same. Okay, now let us do the same for b triple dash. Okay, oh sorry, so now let's do for b triple dash. It will be 2 solving we'll get 154. So 150. Okay, this is the box. And you can check by manually just the case you have add the element 2 and you have find b terms and we have calculated the determinant. Okay, see whatever I have solved here, everything is written here. So this is the new matrix B One more thing you can do here, can calculate once again S value. The method, the process which I have explained to you, can do the same method, same process, and you can find this S value again 80. Okay, you will find the same value of S. You can do by yourself. And this is the second method. You can see both the methods. Here S is equal to 18. Here B dash is equal to 80. B double dash 116. B triple dash 152. So this is the method of calculating S. It's by writing it's looking very difficult to understand, but if you understand the method, the process through which you can calculate the S value, it will be very easy for you. Okay, so now one thing that is discussed here, you know, A dash is A plus S6. You know A double dash 2S6. You know A triple dash 3 6, right? If you do one thing, subtract A dash from A double dash and A dash. If you subtract, you will get S6. If you do A triple dash minus A double dash, you get S6. Okay. If you see clearly, if you subtract this A dash and A dash, will cancel out and you will left with Sx. So I can write in general, if this is an, we have to subtract with an minus 1 bx. If you clearly observe, just you observe these three matrices, it is forming an in each fact, in each successive increasing of matrix within an element x, there is also an increase of Sx. It is added by Sx. It is also added by Sx. Okay, an increment of Sx is observing over here. So this shows the arithmetic nature, the determinant of matrix A. Okay, now as you see, you can write arithmetic progression this way. And if you compare this to let's say it is a plus and terminate on a plus and okay, compare both. We will see the first term is a, is called t1, and common difference d is equal to s into x. Okay, so if you know this Sn formula, okay, you know this formula. So I'm substituting the values. You will get okay, just a minute. This is the formula. It is s into x. Okay, so as this is a determinant, so that's why I'm writing Sn in determinant, because we can assume that if A is a matrix, if you write the AP in the form of matrix, definitely it will show a matrix of arithmetic nature, and the sum of this all matrix will become some matrix Sn. Sn will definitely come some matrix, so that's why I am putting this determinant in Sn also, because the value we are getting is a real number value. Okay, so this is the AP nature of this matrix. So this is the application, you can say. This is the application of this element addition in a matrix, and you can see all the things has been written over here. This is the AP. These are the additions. Okay, in this case, we taking as Tn is equal to delta plus nsx. For this purpose, we are comparing on here. this is the values for this purpose, and this is the sum of matrices. Okay, so now we are doing one example also same way. So if each element is added by 3 in this matrix, sum of the arithmetic progression of successive determinant is added 16 times each. Okay, so if you know the formula, then better. Otherwise, you have to find the determinant of successive element additional matrix 16 times, which will be very difficult to solve. Maybe you have chances of doing any calculation mistake, you will get a wrong answer and you will not get the desired answer. So just we have to need three things. We need S, we need X, we need determinant of A. Okay, for here, as I have taken so much time, so that's why I'm just writing the values. To calculate determinant of Z, you will get 33. If you calculate S in the same way, you will get 11. Okay, and here your X is 3. So I put the values in the formula, and here also N is equal to 60. Okay, put the values 16 upon 2, this 33 plus uh, yeah, just because of little technical equipments with me, it is very difficult to writing on the screen, and I am also cooperating with it. So you also try to cooperate with 15 into 11 into 3. Okay, just do these things and you will get your answer as 4488. Okay, this will be your answer. See, so this is the formula, and these are your values, and these were the values upon calculation. So if you put, this will be your answer. Okay, so next thing is matrix notation. Okay, so what we have studied that it can be written as A plus X, B plus X, C plus X, t plus x. Okay, what happens if I will write like this? I may have uh, written like this way. These all are x, and you know this value is 8, right? So I'm writing like this. If I take x common, it will be 1, 1, 1. It has been like this. Or I can write the form of a plus px, where this p is unit matrix. Maybe you have heard about it, but this matrix never been used in any other numericals, so maybe you forgot this one. But this is a unit matrix, and don't compare it with the identity matrix, not equal to identity matrix. Okay, it's not equal with the identity matrix. Okay, because in identity matrix the condition is that its determinant is becomes 1. Here its determinant becomes 0. You can see one more thing, that determinant of p is 0 here. By the properties of determinants, this determinant will become 0, and you know that if determinant is 0, p inverse does not exist. P inverse does not exist. So that's the case. Here your x you cannot be predict from this notation. Okay, cannot predict the x value from here. If I if you have some questions like that, there are two matrices A and B, and what element x must be added so that only the case the determinant of A plus Sx will become determinant of B. So one point I want to keep with you, that on this x coming from the determinants only, but you think uh, one thing you remember, that whatever x will come, A plus Bx will not be equal to B. Okay, it will not equal to B. So you now understand unit matrix is not equal to identity matrix. That's because the identity matrix determinant is 1, but in case of unit matrix its determinant is 0, and all the elements in unit matrix is 1, but in identity matrix only diagonal elements are 1, remaining other elements are 0. That's the difference between the unit matrix and identity matrix. Okay. So as you see, this is the matrix notation. I have just written there, and here you just written in this form. Okay. So as you see, there is no such formulas available to find the determinant of A dash using this formula. So the formula given in the first heading is the best way to calculate the determinant. The formula, which is A power n equal to that A plus S6. Okay. So one thing you keep in mind that both A and S should be exist. If A is there, then S is there. Both should exist. That means if there is A, then only there is S. If there is no A, then there is no S. Okay. I can give you any. Suppose you can take any A n value. You predict any A n value and calculate its determinant, and you can take any A value and its determinant. You are supposed to take any X and you can find your S. Otherwise, okay, you need to find X. Your S will come from determinant of will come from matrix A. Okay, S will come from A, and you have to imagine one A power n matrix. Okay, your n supposed to write here. Okay, so this is the formula to calculate. If you don't know what is the X, you can calculate X from this value, but it has some limitations. So let us talk about here. So as I told you that the element addition in a matrix can work on the principle of its determinant. It is not working in the property of matrix addition, but it's working on the principle of its determinants. You can see very clearly. If you want to predict the element which is added in the matrix, only determinant property can be used in such case. As I explained to you, so if you have suppose A dash value and if have A value, if you have A value, then you have S value. From this formula only you can predict. It is a determinant property and you cannot use the matrix notation property. Matrix addition property is not usable, which is this one. A dash is equal to A plus Bx. From this formula, you cannot predict X value. Okay. Yeah. Otherwise, if you know A dash and A, what guarantees that your X will be same? If you take any A dash value, you take any A value, and if you subtract A dash minus A, it will come somewhere. But you can observe that your predicted values is not having same. If you subtract A dash and A, there should be each element should be same. Then only you can calculate X value from the matrix addition, but such possibilities are rarely imaginable. I can take any A dash value, I can take any A value, but I cannot predict x value from matrix method. I can predict it from determinant method because and that's it. That is the thing. If A dash you have take some value, you taken one matrix A dash, you taken one matrix A dash, okay, and you calculated x. Upon adding the x element in A matrix, it will come some matrix. So what I am going to say that suppose A dash is a matrix, you know. So you know the determinant also, and there is a matrix A also there. From determinant we have calculated x, but it is not sure that A plus x into P of course. Okay, but determinant of A plus Px will be equal to determinant of A dash. These things you can understand. You can take any example. Okay, you can take suppose I am taking here only 2 by 2 matrix. Let us take suppose uh, B is equal to 2 6 1 8 and A is equal to 1 4 3 6. Okay, you need to find x. So its determinant is 10. Okay, you calculate, you will get your answer. Its determinant is 6 minus 12 minus 6, and you calculate s from here, it will give you 0. Okay, let's say take s is 0, right? Just take 5. Actually your s from previous example came in 0, so you cannot predict x value. So that's why I'm taking another case. This is 5, okay? This is minus 7 and this is minus 1. So upon using the formula 10 is equal to minus 7 minus x, because s is minus 1, okay? So your x is equal to minus 17. Now if I add element minus 17 to each of the case, we will get this value minus 16 minus 13 minus 14 minus 12. This is your answer, and this matrix is not equal to P. But if you see, we erase this part, this is over. If you find this determinant, that is 16 into 12 minus 14 into 30, 12 6 are 78, sorry, 192 minus 13 4 are 52, it will give you 10, okay, and this is equal this one. This is one of the limitations. It happens with this 2 by 2 matrix, and same will happen with 3 by 3 matrix, 4 by 4 matrix, and so on will happen. This is the third point seen. The third point is about this one. If A and B are two different matrices, then the element which is added to A so that it is equal to B is possible only in case of their determinants. Such added element cannot give the matrix B but gives a different matrix whose determinant is equal to that of B, and this is the reason of that limitations. Okay, so from our side also we have provided some questions. These are the assignments you have to solve. You can see and you can read by yourself. Uh, Here, first case, you have to find four matrices: U dash, U double dash, U triple dash, U power 4. And the second question is about one condition that U B dash is equal to B dash square, means B dash is equal to B dash square. That means B into B. This is the property. Okay, this is the property. So one entire given to you. Don't need to, no need to calculate V square matrix. Just you need to find the determinant of V and you can square it. You will get the answer of V square dash. Will be the X value. And also you can make one formula from this property also. That property also you can use it. And the last question is about the arithmetic progression. Is about the arithmetic progression, in which you have to add it 30 times. What will be the sum you have to calculate? Okay. So thank you for cooperate with us, and please like, share, and subscribe to our channel. And feel free to ask your doubts in the comment section. Thank you. If you subscribe us, we will motivate from your side so that we can try to provide you such more interesting videos, interesting topics, interesting lectures. Okay, thank you and bye bye.